Hello everyone. Today in this lecture we are going to discuss about conversion of finite automata into regular expression using Arden's theorem. So Arden's theorem is a theorem which is making use of identities in order to simplify the regular expression. Now coming to this Arden's theorem, so this method is used to find the regular expression which is accepted or recognized by the transition system by making the following assumptions. First of all, the transition system should not have epsilon waves. That means whenever you are resulting in a regular expression, the regular expression should not be left only with an epsilon. First, that care has to be taken. Then second point is there should be only one initial state, say Q0, and all the states are labeled as Q0, Q1, Q2 and so on up to Qn. And we are also taking a new variable here which is nothing but known as V1, which is the regular expression that is representing the set of strings accepted by the transition system, that is nothing but the finite automata, even though if you are having a final state here. And in order to represent the transitions among the states in that particular automata, we are having another notation, say, known as alpha ij, where alpha ij is denoting the regular expression. That means this is going to give the transitions from state qi to qj. If suppose there is a transition defined on state qi to qj, that transition is represented by using alpha ij. If there is no transition, then alpha ij is equals to null. So with this assumptions, what we can do here is we can generate the equations for the regular expression such that V1, V2 and so on up to Vn, where V1 is V1 into alpha 11. That means V1 is nothing but treated as the state of the automata, and alpha 11 is the transition which is coming from state 1 to that state itself. And V2 is nothing but state 2 here, and alpha 21 is nothing but the transition which is coming from state 2 to state 1. Similarly, and so on up to Vn. Vn is the nth state, and alpha n1 is the transition coming from state n to state 1. And finally, we are having this epsilon here. So in the then coming to the second expression, so repeatedly obtaining the equations here, V2 again it can be written like V1 into alpha 12. That means all the transitions that are coming towards state 2 can be written using V2, and so on V3 and so on up to Vn, where finally Vn gives us the final state, that is the accepting states. Now, after obtaining all these V's here, that is the state representations in terms of combining the input state and the transition here, we have to convert all these equations into the form of alphas, that is alpha ij, that is nothing but the transitions, where alpha ij denotes the actual regular expression, and the whole regular expression for all the states. That means, for example, if in the finite automata, if we are having n number of states, where for all that n number of states, in order to obtain the transition, we have to make a union of all these V's correspondingly such that we equate them to the final state. That means we have to arrive at the final state to say that our automata is accepting the given language, thereby the regular expression also. Now, let us construct the regular expression for a given automata by using Arden's theorem here. So, let us take the regular expression here, where here there are three states that are defined, say Q1, Q2 and Q3, where Q1, first point here is, first assumption that we have made is that automata should not have epsilon moves. So here if you see this automata, it doesn't contain any epsilon move, and there should be only one initial state, that is Q1, and final state here. And so now start constructing the v's, that is variables here, let q1 is equals to identify, observe all the transitions that is coming towards this q1. So q1, if we see here, there are two transitions that are coming across this q1 here. So that is q1 on a, and from q2 also we are coming to q1 on the input symbol b. So q1 can be written like q1 is equals to q1 into a plus q2 into b plus epsilon we have already defined, because if your regular expression is based upon an epsilon, for that also we have a finite automata. So for that reason we are using this epsilon here. Now similarly observe, write the equation for q2, writing the equation for q2 here. If we observe, q2 is having three incoming transactions like from q1, q2 and q3. So q2 can be written like q1 into a plus q2 into b plus q3 into a, which is nothing but q2 is equals to q1 into a plus q2 into b plus q3 into a. And now if we see the last final state q3, so it is having only one incoming transaction, and that is also from the state q2. So this is written as q2 into a, and thereby q3 is equals to q2 into a. Now where these are all the v's we got, these are all the v's we got in terms of q1, q2, q3. And now what is that we have to do is, by making use of the identities and the Arden's theorem, we can construct a regular expression from these three equations. So let us look here. So just taking all the equations here, q1, q2 and q3. Now substitute the value of q3 is equals to q2a in this q2 here. So substituting the value of q3 is equals to q2 into a in q2, the equation becomes q2 is equals to q1 into a plus q2 into b plus q2 into a into a. So that can be also written like q2 is equals to q1 into a plus q2 into b plus a. Now if you make use of the Arden's theorem, that is r is equals to q plus r into p. So where r is q2 and q is q1a and p is b plus a, then q2 can be written as qp star, that is q1 into a into b plus a whole star. So now we got q2, that means we have simplified this q2 in terms of q1 into a into b plus a whole star. Now let us simplify q1 by substituting this value which we have obtained here in q2. So now considering the equation here, substituting the value of q2 in q1 here, so q1 is equals to q1 into a plus q2 into b plus epsilon, where q2 here we are going to substitute. So q1 is equals to q1 into a plus q2 we have obtained like q1 into a into b plus a whole star into b plus epsilon. So now again, so simplifying this q1 into a plus a into b plus a whole star into b plus epsilon. Again making use of Arden's theorem here, let r is equals to q plus rp, where q is epsilon here and r is q1, and this is what p, a plus a into b plus a whole star into b. So therefore q1 can be written like qp star, that is epsilon into this particular whole expression. So epsilon into r star will be giving the r star again from the identity. So q1 is written like a plus a into b plus a whole star into b star. Now subsequently replacing the value of q1 in q2 and q2 in q3. So that means q1 in q2. That means q2 we have obtained like q2 is equals to q1 into a into b plus a whole star. So substitute this value of q1 into this one, that is A plus A into B plus AA whole star into B star. And again substitute the value of Q2 in Q3, that is Q3 is equals to Q2A, right? So this becomes A plus A into B plus AA whole star into B whole star into A into B plus AA whole star into A, where this is what the regular expression that you can get for the finite automata that is given. Hence, we have, as Q3 is the final state, we can conclude that this is the regular expression that can be constructed for the given finite automata. Thank you.